So today we're going to take a look at luminous and non-luminous objects. So let's take a look at what a luminous versus a non-luminous object is. So a luminous object is said to give off its own light, whereas a non-luminous object is said to reflect light. So a non-luminous object does not produce its own light. We can still see it because it's reflecting the light of a luminous object. So the most obvious luminous object we talk about is the sun. The sun does give off its own light. That's why we're able to see it. Whereas the moon up in the sky does not give off its own light. The moon actually reflects light. Doesn't mean we can't still see the moon. You can still see the moon. It's very bright in the night sky. It's not the moon's own light though. It's the moon reflecting sunlight back to our eye. Other examples of luminous objects, light bulbs, flashlights. Examples of non-luminous objects, trees. So again, at night, if you get close enough, you can see a tree because it's reflecting sunlight back onto your eye. We're going to take a look at 7 different types of luminous objects. So we talked about the sun, flashlight, light bulb. Each of them can be categorized differently based off of how they're able to produce their light. The first and probably the most popular that you have in your house is something called incandescence. So incandescence is the production of light as a result of high temperature. So you probably have a lot of new efficient light bulbs in your house, but if you have any of these old school light bulbs, you might have touched them before. Be very careful when you touch them because they get extremely hot. So how incandescence actually produces its heat is it goes to very, very high temperatures and you're able to actually see light, or it looks almost like a glowing. Other examples beside light bulbs are fire. So there's a lot of heat involved in combustion, fire. That heat produces light. Or the sun itself. The sun is actually caused, the light's caused by a chemical reaction. Again, very, very high temperatures. That chemical reaction, you can see the light happening. So the sun is an example of incandescence. Another example, and you might have seen this before too, is phosphorescence. So phosphorescence, we can produce light by absorbing UV ultraviolet light. So remember when we talked about the electromagnetic spectrum, visible light was its own little strand and UV light was actually right above visible light. So UV light, typically we can't see. It is given off by the sun. So phosphorescence is able to absorb UV and take that UV and give off visible light. Oftentimes this visible light is given off over an extended amount of time, even when the UV lights aren't present anymore. So if you had any of these beautiful glow-in-the-dark people here, this is a ghost. I know I had glow-in-the-dark stars in my room. What would happen is during the daylight hours, it would absorb that UV from the sun, and then at nighttime, it could give off that light over long periods of time. So glow-in-the-dark watches, keychains, all use phosphorescence to produce light. They're considered luminous objects. Fluorescence is similar, but slightly different. Fluorescence is the immediate emission of visible light as a result of UV absorption. So it still uses UV, which we typically can't see, to make visible light. The difference here is fluorescence is a really bright color right away. So it's that visible light right away from UV. It's not able to absorb and store that energy, so it doesn't give light over a long period of time. So when UV light is present, when you have light in the room, you can see the really bright color of a highlighter. If you turn off the lights, and there's no UV light present, highlighters don't appear to glow in the dark because they're not able to give that energy over a long period of time. Fluorescent lights are considered an example of fluorescence, as are highlighters, like I mentioned before. Chemiluminescence, this is probably my favorite. Chemistry plug, love it, right? So chemiluminescence is the direct production of light as a result of a chemical reaction with little or no heat. So this is different than incandescence. Incandescence, some of them can use chemical reactions. Here it's a chemical reaction, but there's little to no heat being produced. Best example I can think of is glow sticks. So within glow sticks, there's actually a very thin metal vial, and there's an outside. That thin metal vial allows you to separate your two reactants. That's why to actually have a glow stick glow, you have to crack it. When you crack it, you're breaking the glass, you're allowing the two reactants to mix, and it's giving off light as a result. So it's again a sign of a chemical reaction. Glow sticks don't last forever because eventually you will run out of one of the reactants. So one of the reactants will get used up. Once one of the reactants is used up, the reaction is no longer going to happen. So glow sticks are a great short-term way to produce light. There are different ways to extend the life of glow sticks. So for example, if you can use heat or cold, heating the glow stick will actually speed up the reaction. So it'll glow brighter, but for less time. By cooling the glow stick, it'll slow down the chemical reaction. So it'll be not as bright, but it'll last for a longer period of time. Bioluminescence is pretty cool, one of nature's coolest things. It's a production of light in living organisms. It's a result of a chemical reaction, and there is little to no heat being produced. So oftentimes there's bacteria that can actually use different chemicals to create their own light, and those bacteria reside in a lot of different organisms. Some other organisms can produce light on their own as well too. Glowworms are a great example. So they're able to use chemicals to produce light with little to no heat. Fireflies go by bioluminescence. The anglerfish, if you've ever seen Finding Nemo before, totally terrifying, right? Those giant teeth and that little light hanging from the top. Or jellyfish also undergo bioluminescence. Triboluminescence. This is one that you can actually see at home if you have wintergreen mints. So triboluminescence is the production of light from a friction as a result of scratching, crushing, or rubbing certain crystals. So essentially you have two different crystals and you can either rub those together, or you can have the crystal and you can rub it with a hard object, and it's going to cause almost like a sparking, and those sparks are going to be luminous. So wintergreen mints, those little lifesavers, you might have seen them before. They're those white lifesavers, and you have to get the white lifesavers with the green dots in them. The green dots are actually crystals that undergo triboluminescence. Those are the wintergreen flavored dots. So if you get one of those mints and you actually put it in your back teeth and you stand in a really dark room and you look in the mirror and keep your mouth open, you can actually crush the wintergreen mint with your teeth and you're going to see almost sparks kind of coming out in your mouth. That's an example of triboluminescence. So the crystals are being crushed by your teeth, and when they're crushed by your teeth, they're releasing those sparks, that luminous light, through triboluminescence. Last one is one that you might have seen in your home as well too. Sometimes we refer to it as LED. LED stands for light emitting diode. A light emitting diode is a light that's produced as a result of an electrical current flowing through a semiconductor. So here we have our electrical current flowing through. We have a semiconductor right here, and that's going to allow that's going to allow light to be produced. What a semiconductor is it's a material that allows an electric current to flow only in one direction. So we're going to see just a flow of electricity in one direction. That flow of electricity in just one direction, through that spot, it controls the flow of electrons, and we're able to get a light that's produced. So that's how we categorize luminous objects, is into those 7 different categories. This unit, we're going to be studying light. So we're going to be using luminous objects, and we're either going to study them themselves, or we're going to go ahead and see how they reflect light off of other objects, and we're going to talk about that reflection and that light traveling from our luminous objects and either bouncing off or going through other objects. So next up, we kind of start part 1 of our 2-part series of light rays, and we're going to look at the ray model of light, and we're going to start by studying mirrors. So check out the next video, and we'll keep going with physics.